Now with what is dark matter and why does it matter? Now we'll be introducing the new presenter.
Let's give a nice round.
Let's give a nice round of applause.
So what is dark matter and why does it matter? For those of you who don't know me, my name is Charlotte Wunn Casado. I'm in 9th grade and very fascinated by the universe. And today I would like to share a bit of that fascination with you. Do you ever wonder what the universe is really made up of? Well, of course, it's all of the things that we see, for example, galaxies and stars and planets. But what about everything that you cannot see? That is dark energy and dark matter. But for today, I'll just focus on dark matter. In the currently popular model of the universe, it is estimated that 70% is made up of dark energy, 25% dark matter, and 5% normal matter. And by normal matter, it is meant the matter which we can see. The reason why we cannot see dark matter is that it does not emit, absorb, or reflect any light or electromagnetic radiation. But how can you even detect something that you cannot see? Well, the first person to use the term dark matter was the Swiss astronomer Fritz Zwicky in 1933. He was trying to understand the behavior of galaxies, especially in the Coma cluster, and specifically the Coma Berenices. Now, a cluster is where multiple galaxies cluster up to form a cluster, and they orbit around each other. Now, what Zwicky found was that the galaxy which he was studying was rotating about 100 times faster than the theory predicted. But the known mass of the galaxy was not enough to account for such fast orbits. In fact, it must have weighed 400 times more than what it actually did, because the gravitational effect of the cluster was too low for such fast orbits. If you can picture one of those small carousels on a playground, your mass and your position on that carousel plays a big role in the speed of rotation. And that's the same principle for galaxies. And what Zwicky found was that the mass of the galaxy was, exactly as I said, not enough for such fast orbits. Now, this led him to the theory of dark matter, but his theory was named absurd and set aside. Later in the 70s, Vera Rubin, an American astronomer, worked on the motion of spiral galaxies, specifically that of the Andromeda. And she found the same thing Zwicky had claimed 40 years ago. Today, it is confirmed that dark matter exists, and it is even thought that it makes up 85% of the universe's entire mass. Now, what exactly even is dark matter? On a basic level, you can imagine it as a strange scaffolding halo which controls how matter acts. It is known that dark matter was created in the Big Bang. And however, we're still not sure what exactly it is made up of. And there are many theories of what it cannot be made up of and fewer of what it actually could be. Dark matter may be made up of brown dwarfs, which are failed stars which never ignited because they did not have the required mass to start burning. It could also be white dwarfs, which are the remainders of cores of medium-sized stars. Or it could be black holes and neutron stars, which are the remnants of large stars which have exploded. However, there's a problem with each of these possibilities, because it is known that there are too little brown and white dwarfs to account for all of the missing matter, and neutron stars and black holes are just far too rare. So dark matter may be made up of a particle which we are not familiar with at all, and which is at the moment only a prediction. And the leading theory for that right now is the Wunn, which is a weakly interactive massive particle. Now, this is only a hypothetical particle and yet to be detected by scientists. Now, just as a quick fun fact, did you know that it is estimated that millions of dark matter particles are seeping through you right now? But because they barely interact with any normal matter, you cannot notice a thing. Now, the next question we must ask ourselves is, that if dark matter barely interacts with normal matter, how come scientists are able to detect it? Now there are various methods, but the one which I will explain to you now is the Cryogenic Dark Matter Search, short CDMS. This experiment is located very deep underground in Minnesota, in the Sudan Underground Laboratory. There they use germanium and silicon crystals, which are in the size of a hockey puck, as you can see in the picture, and they are cooled to temperatures close to absolute zero. And they are shielded as best as possible from normal radiation, which could mimic dark matter signals. And then what they do is just wait. They wait for a dark matter particle to hit the nucleus of an atom. And because it is so cold, this small vibration can easily be detected. The experiment has been running since 2013, but until today, they have only detected very few results, which could be candidates for dark matter particles. So a lot more evidence is needed to fully confirm the detection of dark matter particles. Now, something I was wondering while I was doing my research is that if millions of dark matter particles are seeping through me right now, how come there are so little results? Well, the problem was I was looking at a far too large scale. The chance of a dark matter particle hitting exactly the nucleus of an atom, that is such a small chance. To visualize it, it would be as if I would try to shoot an arrow onto a target that is 1 mile away from me, and I would try to hit exactly the bullseye. So that chance is extremely low. Finally, let's summarize everything that I've said in this presentation. So we know that dark matter was discovered in 1933 by Fritz Zwicky, and scientists also know that dark matter must exist because without it, stars and galaxies would not form at the rate which they do. Because their gravitational force alone is not enough to hold them together. So there must be another type of matter which is extremely high in mass, which therefore also creates large gravitational force, which then allows normal matter to form and form stars and eventually galaxies. Now, scientists also know that it was created in the Big Bang, but they're still not sure what exactly it is made up of. But the leading theory is the hypothetical Wunn. So once again, what is dark matter? It's just another type of matter which is extremely high in mass and which we cannot see because it does not absorb, reflect, or emit any light or electromagnetic radiation. Scientists know that without dark matter, our universe would look extremely different from what it does today. And you and I would most probably not exist. Thank you very much